My name is Bogum Choi, and I'm here to present the paper Procedural Knowledge Search by Intelligence Analysts. This is a work done at the University of North Carolina at Chapel Hill in collaboration with Laboratory for Analytic Science at NC State University. So let's first define procedural knowledge. Procedural knowledge is knowledge about how to do things. It is an understanding of when and how to use a specific procedure. The knowledge is exercised in the performance of a real-world task, and it's often considered in the context of problem solving and operation of tools and equipment. Our overall research question was, what are the needs and challenges people experience during PK search? And what can systems do to support it? To investigate this, we studied a specific case where intelligence analysts search for procedural knowledge using an internal system called Tradecraft Hub. So our user group was IAs who are employed by the US National Security Agency, who perform analytic tasks using a variety of technologies, tools, and data sources on a daily basis. And they have a searchable system called TC Hub, which is basically a repository of procedural documents. TC Hub documents consist of articles describing how analysts use specific tools, technologies, and data sources to conduct their work tasks. An important thing is that it is a grassroots system. Most documents in the collections are written by IAs for other IAs because the point of the system is to make the procedure knowledge gained from work experience accessible to other IAs. We explored 4 research questions related to the IA's use of the TC Hub: work task objectives, information types sought, relevance criteria, and challenges faced. Although we are going to present all the findings of these questions, due to the time limit, I'm going to highlight only a couple things on each slide. So please take notes of questions as they come up and reserve them for discussions. We conducted a survey study with the TC Hub users. We surveyed 22 IAs, all active users of the TC Hub. One important thing to mention here is that due to the confidentiality and non-disclosure agreements our government workers have, they couldn't really discuss their work as is. But we had to ask them about their work tasks so we know the context of their search. So we gave our participants special instructions to use analogies and generic descriptions in their responses. It was a unique data collection challenge we had, but we are glad to report that it actually worked really well. And we believe that this could be a methodological contribution to research where you need to work with participants with strict confidentiality agreement. To analyze the data, we conducted qualitative analysis on IA survey responses. So, to learn about work task objectives that motivated the search, we asked participants what work task objectives they were trying to achieve when searching the TC Hub. We gathered all responses and classified them based on the main verb and noun used in their work task descriptions. For example, if a participant said, I was trying to evaluate whether tool A can replace tool B, the verb evaluate and the noun tool were recorded. We adopted Anderson and Krausel's taxonomy of learning to create a 2-dimensional table consisting of main cognitive activities and the artifacts involved in our participants' work task objectives. So here is the table. We've got the verbs on the rows that denote the main cognitive activities and the nouns on the columns that represent the main artifacts our participants were dealing with, which include data, tool, technology, process/method, and general knowledge. I'll highlight 2 main takeaways from this categorization table. First, since we were examining work tasks that motivated procedural search, we expected the most common objective to involve apply. However, the most common involved understand and evaluate. This suggests that real-world versions of procedural tasks require understanding and involve cognitive processes that are more complex than applying alone. Second, analysts use the TC Hub to support a wide range of objectives. The distribution of the objectives followed a long-tailed distribution, meaning that few objectives were frequent and most were rare. This suggests that the system must be designed to support many different types of objectives and task scenarios. We identified different types of information sought by participants: background information, definitions of key terms and concepts, detailed step-by-step instructions, and advice from people with firsthand experience. Interestingly, when participants sought detailed steps, they also wanted information about the why of specific steps, which suggests a desire to modify procedures to fit their task scenarios when needed. In terms of relevance criteria, we found that complexity of information content can be unpacked into three related yet distinct categories: intended audience, level of details, and level of specificity. Level of details pertains to the amount of details included in a document and how self-contained the document is. Can I tackle my problem with this single document, or do I have to consult multiple resources? Level of specificity and generalizability was an interesting one. Sometimes participants wanted something that's highly specific, but other times they wanted to see generalizable principles or rules that can be applied across scenarios or tasks of the same type. Participants talked about challenges that they had, and I'll talk about the first four. The first challenge was having to wade through a lot of information just to determine the relevance of a document. At a page level, long documents with no standardized structure made it difficult to locate buried information. Vocabulary problems involve not knowing how to formulate an effective query and not understanding technical jargon in documents. Gaps mean missing content on a certain topic or of a certain type in the collection. And categorization mismatch happens when a document is classified by the author in the way that it didn't match the reader's expectation. To address these challenges in the paper, we suggested a number of design implications and future directions for the system. First, we can explore the ways to make the relevance criteria we identified into facets by which people can filter the results. Second, to reduce the time and effort spent on wading through a dense document, the system can highlight the information that can be used by users themselves to determine the procedural applicability, such as prerequisites or constraints. Other design implications include providing an easy, standardized way of tagging the document, using the system to connect people, and leveraging users' previous interactions to detect the gap in the collection. I'll be happy to talk more about all the above in the discussion, so please ask questions and share your thoughts. Thank you for listening to my presentation.